Yes, dear students, in this video we are going to discuss about the threading experiment or CNC path programming. We are discussing about the lathe path programming. In this threading experiment, how to do a threading operation in the CNC lathe. The aim of this experiment is write a path program for the threading operation, and we have to show the simulation using the simulation software. So let me see what is the threading operation. It says here it is given diameter 20, and for the distance totally it is 40 plus 25 and 5. So here it is 70. We are writing the billet size as X20 and Z70 since it is 20, 70. Raw material is 20, 70. Okay. In this, we are going to make a threading. This is the threading for this until 40 mm distance. We are making M12 thread, and then 5 mm gap over here. Here we are going to make the step. So the job what it is given directly, we are not going to do the threading operation here. First of all, we should know what are all the operations here. So in this raw material, first operation is we have to remove this 20 mm distance into this 45 mm length. So 20 to this should be reduced to 12 mm. Okay, for a 45 mm length. Then we are going for the grooving threading operation. So two operations are we are going to do here. So first one is we have to use box turning cycle. We know what is a box turning cycle. A cycle which is going to use for repeated operation, that raw material is to be removed in terms of, okay, this is the tool movement has to, this is the area which we have to remove. So box turning is going to be used to remove this area. How it is, the tool has to come and it has to move to this direction, it has to move upward, and it has to move this direction. So the cycle will takes place and to remove this entire area. So this is the area which is to be removed. So we are going to use this one. So for that G90, we know the box turning cycle is a G90. So G90, X is at F. F is the feed. X is at F. So from which diameter to which diameter we are going to reduce, that is very important. So from 20 diameter to 12 diameter I am going to reduce this area. So this G90 will help for reducing the diameter from one major dia 20 to M12. Okay, first once this is over, then we are going for the threading G92. The G92 is used for threading operation. So what is the X and Z coordination points? And see here you can see only the threading is going for 40 mm. So and moreover the pitch has to give. Okay, here it is given 1.7 mm pitch. Okay, since it is not shown in the figure here, but they have given as in the question that they will give what is the pitch for this. So here 1.75 mm pitch is given. Okay, let me calculate this. What is the height of the thread? So any thread, we know that a thread will be here. This is the thread. So for this thread, so we have to make the height. Okay, we have to calculate the height of the thread. So this is, we know this is the height. Okay, so pitch is a thing where the distance between the same points of the two consecutive similar threads, we call it as a pitch here. So once if we know the pitch, by using the thing, we are going to calculate the value. Okay, calculation of the height of the thread here. So we call it as pitch is 1.75. Okay, it is given 1.75, it is given. So the formula is 0.613 into F. So if you know the point value, that is 1.074. So you can see this is the 1 point, to find this is the 1.074, and here is 1.074. So 2 times of 1.74 will be there. Okay, so normally thread. So I'm showing here, this is the thread over here, and this is the, just we are showing I think, and this is the diameter here what it is given, and what we have to find is this diameter, core diameter. So this is what we have to find. So this is 1 and this is 2. Here this height and this height, if you reduce, this is the capital D, and if you reduce this capital that is 2p, here one P is there. This is the P is not pitch here. We call it as the depth or height of the thread. So P plus P 2P. D minus 2P we will get this core dia. That's all. If you find this core dia, then we can go for the program. The program is normal as usual. We will fill all the first steps. Program number G2898, G21, G98, and that is the home position. Tool selection, tool which is the, we are going to use the box turning. First we are reducing the size here. So box turning, I am going to use G90 from X19, X22. I am going to reduce until X12. This is the box turning cycle for a distance of 45 mm. So I am going to reduce for the distance of 45 mm from this 20 to this 12. Okay, this is first thing we have to do by selecting a one tool, any tool. Okay, multiple turning cycle, any tool I am going to select. After that, I am going to home position return, select another tool which is having a threading operation. So that is the threading tool. I am selecting another tool. So by using that, again I am bringing the tool to this position. So now this is the job. Already we have made a step turning like this. Now I am bringing the tool here for making the threading for a 40 mm distance. So this is the operation. By using G92, we are writing X12 is the diameter for Z minus 40 mm distance with the pitch rate. I am reducing this diameter until my core diameter. This is what the core diameter we have calculated here in this formula. This is 9.853. So from this major diameter 12 to, I am going to reduce this for the core diameter. So this is what the thread it is going to be replicated here. So the thread is very important. We are going to make it, and after completion of this program, we are writing G28U0W0, M05 for spindle stop, M30 for program stop. So this all should be written in a manner, and then it is to be showed in simulation. Okay, this is how the taper for the thread cutting program. Okay, now we have to show the simulation for this. Let me go for the simulation. Right. Now for this program we are going for the simulation of the threading. So how to do the simulation of the threading? So again what we have to do is we have to go for the CNC turning. So file I am going to make a new one. So already what it is there I removed, and now we are going for the new program. So in the new program, what I am going to do is just I am copy paste the program what we have written already. So and either it may be in the terms of Word or in any notepad, you can copy and paste. So if it is written in this manner, it will be easier for editing. Okay, so after this is what, Control C, and at the bottom Control V. So all assure, let me assure this the program is in correct order. So the thing is, first we are writing the program number, and for billet size is 20 and Z70, that is the raw material which is shown here. For this we are going to make the threading operation. So M12, and for the pitch of 1.75 it is given. So now we are going to solve the problem here. So one the thing is the calculation portion is very important, that where what is the core diameter 9.853 and what is the depth of this thread is 1.074. So let it be here, and once we are copy paste this one, first we will assure that everything is in the order, metric input and feed per minute. Okay, fine. M06 tool number, M03 for spindle rotation. These are all the basic concepts for all programs. After that we are writing the program number from N10 to N100, and here we are not going to copy paste any program block number, starting block or ending block, but the thing is we are writing here. And this is the box turning cycle, as we said. So first of all we have to reduce the diameter from 20 to 12, then we have to go for the another tool. So first tool, select one tool. The first tool is I am selecting a turning tool, either the tool station may be 1 or 2 or 3, whatever it is. So that by using this box turning will be done. After completion of this box turning, we have to go for home position G28U0W0, Then there we are taking another tool which is for threading. So N06 is the tool code which is used for selection of the tool, and from there again I will bring the tool to the position where it is to be drilled. Okay, here the threading operation to be taken place. So we are bringing the tool to the X12 diameter to the Z1. So that we are writing here, and then threading cycle G92. So this is the box threading cycle G92. X Z is minus 40 because the distance what the threading we are going to take is 40 mm distance. So minus 40, Z is minus 40, and the X value, it starts from 12 mm and it sends to the core diameter value, that is 9.83. So just to reduce a little bit, 0.2, 0.6, 0.4, whatever it is, we can, it depends upon the material what we are going to do. According to that we can give the depth of cut. So here that is G28U0W0, that is home position written. M05 the spindle stop, and M30 is the program stop. Once if it is done, then we will go for this. The program is written here. I am going to select the blank size. The blank size, what it is, the size of the raw material. So the size of the raw material given here clearly is, what is the raw material size in the question paper itself, it is there. So 20 and 70. So I am going to use length is 70 and diameter 20. Okay, so length and diameter we have given here. After this, just I am going to make the blank size is over. Machine, select the machine, type A, fine. Then syntax, check for the syntax. If there is a error, we have to rectify. Now it shows 3 and 8. What is the 3 and 8? Because here we have given tool number 3 and another is tool number 8. So first we are selecting external turning, tool number 3. So this is what we are doing. I am reducing the nose radius. Other than that, nothing I am not changing. I am reducing to 0.5, 0.2 nose radius. So this is given OK. So external turning for box turning, and then I am going for a threading operation. So here we have to be clear. So which tool we have to select? So external thread operation. So select some external thread tools here. We can select this tool here, and 20, 20, 16, 16. This is the edit. If you go and see, you can check this. What is the 16 holder width? Okay, and maximum thread depth is given here. So the thread depth what we have calculated, better we can put that one, so that you can get exactly the value here, simulation of that. So what is the calculation part we have done here is, we are finding this height value 1.074, right? So that is the depth. We maximum thread depth is okay, so we can give this 1.074. So what is this calculation exactly? That is 1.074. I am going to make this 1.074 here. So give OK, right? So that's, it's okay, giving OK, okay, fine. That's all. Now I am going to make simulation. So simulation, play. Just again, if I play this, the tool from now it shows the tool selection. It comes here, and now box turning is going to take place. G90. So box turning. If you click here, it will take box turning operation. So from the diameter, you can make a feed, and you can set it now X19, X18. Line by line we have to select, or else by selecting this end, automatically it will go for fully. We need not to go for line by line. If you select that end, automatically it will go fully. So box turning, once it is over, then it goes for the tool number 2, that is threading tool. So here it shows the threading for you. So if the program, the simulation, that's what the simulation, it depends upon the simulation, we can select this one. So external thread, we can go for the external thread and select some thread here. So external groove, not external thread. So external thread, it depends upon the thread maximum depth or what we have given here, it depends upon 1.75. I give 2 mm depth, okay, minimum give, okay, okay. So okay, that's what it shows here. You can see the simulation, so for the threading operation. It depends, if the program we are writing clearly, then you will get the clear thread. So sometimes it's a simulation problem, it will come there, the graphics problem, graphical problem, so we need not worry about that, but threading will take place for the pitch. So okay, so here this is what, how we have to make this program, right?